Hi students, my name is Lakshmi Pallavi, Assistant Professor in BSH Mathematics from B.V. Raju Institute of Technology, Narsapur, and I am teaching about the course Linear Algebra and Calculus, and today we will be studying about system of linear equations. And system of linear equations, in that particularly we will be studying about non-homogeneous system of linear equations. A great application of matrices is that we will be solving a system of equations using the matrices. So a system of equations means an equation, or we are having if more than two or three variables or more than two or three equations can be solved easily with the help of system of equations. Generally, if you have two equations and two unknowns, we can solve them by elimination method. We can solve them. If you have three equations and three unknowns, okay, it is a bit okay. But if we have four equations and four unknowns, it is very difficult to solve using any of the methods. So wherein these matrices play a very important role in which where we solve a system of equations using the matrices. In solving a system of equations, there are two kinds of system of equations. One is non-homogeneous system of equations, and the other one is homogeneous system of equations. Homogeneous system of equations. In non-homogeneous system of equations, we write it as Ax equal to b, where A is the coefficient matrix, X is the unknown matrix, and B is the matrix which is on the RHS. And homogeneous system of equations, we write Ax equal to 0. So these system of equations are said to have a solution, or we say that these system of equations are consistent if they have a solution. If they don't have a solution, we call them as inconsistent system of equations. So first, let us see how to solve a non-homogeneous system of equations. Whenever you are given a system of non-homogeneous system of equations, first thing what we do is we will write it in the form of Ax equal to b. We will write it in the form of Ax equal to b. So let us see how a non-homogeneous system of equations are looking like. They look like this: a11x1 plus a12x2 plus so on, a1n xn equal to b1, a21x1 plus a22x2 plus so on, a2n xn equal to b2, and am1 x1 plus am2 x2 plus so on, amn xn equal to bn. This is how we have a non-homogeneous system of equations. Now writing them as Ax equal to b. So where A is the coefficient matrix, that is a11, a12 so on up to a1n, a21, a22 so on up to a2n, and am1, am2 so on amn. And the unknown matrix X is x1, x2 so on up to xn, equal to the matrix B, that is b1, b2 so on up to bn. This is how we write the system of equations. That is our step 1. Then we write the augmented matrix. Step 2 is we write the augmented matrix. Augmented matrix is the matrix A along with the matrix B. The matrix A along with the matrix B is called as the augmented matrix. That means we write the matrix A totally, and in the last column we will be writing the matrix B. That is called as augmented matrix. Then the third step is we will find the rank of the augmented matrix using echelon form. We will find the rank of the augmented matrix using echelon form. So depending on the rank of the augmented matrix, we will be deciding whether the given system has a unique solution or infinitely many solutions or no solution. So if rank of A is equal to rank of AB, that is equal to number of unknowns, then it is said to have a unique solution. When rank of A is equal to rank of AB, which is equal to the number of unknowns, then the system is said to have a unique solution. Then, if rank of A is equal to rank of AB, that is less than number of unknowns, that is less than number of unknowns, then the system is said to be have infinite solutions or many solutions. It is said to have infinite solutions or many solutions. Then if rank of A is not equal to rank of AB, then the system is said to have no solution. The system is said to have no solution. So in the first two cases it is consistent, and in the third case it is inconsistent. Yeah. So what are we doing in system of non-homogeneous linear equations? We are first writing the given system as Ax equal to B. Then we write the augmented matrix, that is the matrix A along with the matrix B or the matrix on the RHS. After finding this, we will find the rank of A, B, that is the rank of the augmented matrix. Depending on the rank of the augmented matrix, we will be telling whether the given system has unique solution or many solutions or no solution. Once we get this, which kind of solution it is falling into, then we will find the solution using backward substitution method. Using backward substitution method, we will find the solution. Using the backward substitution method, we will find the solution of the given system of equations. So let us see one problem. 2x plus y. Yeah, this is the given system of equations. Now let us write it in the form of the matrix, that is Ax equal to B. So you will get 2, 1, minus 1, 3, 1, 1, 1, minus 1, 3, 2, minus 1, 0, 4, yeah, we don't have x term, so x is 0, 0, 4, 3, 2 into x, y, z, w equal to 8 minus 2, 6 minus 8. This is how we write it in the form of Ax equal to B. Now write the augmented matrix. Augmented matrix is the matrix A along with the matrix B. So it is 2, 1, minus 1, 3, 1, 1, 1, minus 1, 3, 2, minus 1, 0, 0, 4, 3, 2, along with the matrix B, that is 8, minus 2, 6 and minus 8. Okay. Now let us convert this matrix into echelon form. So whenever we want to convert this into echelon form, what we have to do in echelon form of a matrix, always if there are any zero rows, they should be placed at the bottom of the matrix, and the number of zeros before the non-zero element in any it should be increasing as we proceed from first row to the last row. So let us exchange row 2 with row 1. Yeah, this is not compulsory, but we are making it just to make the calculation simple. So it will become 1, 1, 1, minus 1, 2, 1, minus 1, 3, 3, 2, minus 1, 0, 0, 4, 3, 2, minus 2, 8, 6, minus 8. Now, using row 1, let us make other two elements zeros in the first column. So, R2 implies R2 minus 2R1. R3 implies R3 minus 3R1. There is no need to make row 4 because it is already 0. So first row is not changing. Yeah. This is the matrix which we get upon applying these row operations. What we have done, in the first row there are no zeros. So in the second row before non-zero element we have got 1 0. Now in the third row before non-zero element we should bring 2 zeros. So let us make this -1 and 4 as zeros in order to bring this matrix into echelon form. So R3 implies R3 minus R1 and R4 implies R4 plus 4 R2. Sorry, R3 implies R3 minus R2. So first row is not changing. Second row is also not changing. Now come to the third row, R3 minus R2. So it is 0, 0, minus 1, minus 2, 0. Then R4 plus 4 R2. So 0, 0, 9, 22, and sorry, minus 22, and this will be minus 40. Yeah, and this will be R4 plus 4 R2. This is 0. 3 minus 12 is minus 9. So 0 minus 9, 22, 40. This is what we are going to get. Now let us make this minus 9 as zeros using the row 3. So row 4 implies row 4 minus 9 times of row 3. Row 4 minus 9 times of row 3. Zero, 0, 0. Then it will be it is row 4 minus 9 times of row 3. So it is 22 plus 18. So it is 40 and 40. This is what we are going to get. Now you can see the number of zeros are constantly increasing. In the first row before non-zero element there are no zeros. In the second row before non-zero element there is 1 0. In the third row before non-zero element there are 2 zeros. And in the fourth row before non-zero element there are 3 zeros. So this matrix is in echelon form. Now the number of non-zero rows will become rank of the matrix. So what we can say, rank of A is 4 because there are 4 non-zero rows. Rank of A is 4 and rank of AB is also 4. Rank of AB is also 4 because there are 4 non-zero rows in AB. And the number of unknowns are also 4 because we are finding X, Y, Z and W. So rank of A is 4, rank of AB is 4, number of unknowns are also 4. Then in this case, we are going to have a unique solution. We are going to have a unique solution. So let us find this unique solution using the backward distribution method. So what we are going to do is, whatever this matrix we got, we multiply it with X, Y, Z, W and then we equate it to the matrix which is there on the other side of this. So by doing like that, what we are getting is, Yeah, this is what we are getting by changing that into this form. So from here we can say W equal to 1. So if you substitute this value of W in the before equation, then what you will get? Z plus 2 equal to 0 or Z equal to minus 2. Now substitute the value of W and Z in the second equation. So we will get y minus 6 minus 5 equal to minus 12 or y equal to minus 1. Now substitute the value of y, z and w in the first equation. Then we will get x minus 1 minus 2 minus 1 equal to minus 2 or x equal to 2. So the unknown matrix is 2 minus 1 minus 2 1. This is the unknown matrix which we are going to get. So this is how we find the solution of any given matrix which is have any given system of equations which are having a unique solution. So let us see one more problem. X minus yeah. This is the given system of equations. Now let us try to find out whether this system of equations are having unique solution or no solution or many solutions. So first write it in the form of Ax equal to b. So it will become 1 minus 4 7 3 8 minus 2 7 minus 8 26 into x y z equal to 14, 13 and 5. Now write the augmented matrix, that is matrix A along with the matrix B. Let us write the augmented matrix. This is the augmented matrix. Yeah. Now let us bring this matrix A into echelon form and then find its rank. So R2 implies R2 minus 3R1 and R3 implies R3 minus 7R1. So upon making these operations, yeah, we will get this. Yeah, this is the matrix we are getting upon making these operations, that is R2 implies R2 minus 3R1 and R3 implies R3 minus 7R1. We are doing this because we want the number of zeros to be increasing before the non-zero element. In the first row there are no zeros, so in the second row before non-zero element we got 1 0. In the third row before non-zero element we should get 2 zeros. So for that, let us take this operation. R3 implies R3 minus R2. So we are getting 0, 0, 0, 122. Yeah. Now we can say that this matrix is in echelon form, because if you ignore the last row, last column, if you ignore the last column and then check here, only this part, if you check here, you can see that there is a 0 row which is placed at the end of the matrix and the number of zeros are constantly increasing. So from this we can say that rank of A is 2 and rank of AB is 3. Yeah, rank of A is 2, whereas rank of AB is 3. Since rank of A is not equal to rank of AB, we say that the system has no solution. The system has no solution. Yeah, the system as rank of A is not equal to rank of AB, the system has no solution. The given system of equations does not have any solution. Let us see one more kind of problem. We are given a system of equations, and in this system of equations you were given two unknowns, that is alpha and beta. So for what values of alpha and beta this given system of equations will have no solution, unique solution and infinite many solutions is the question. So let us take this system of equations. X plus 2y plus z equal to 8. Yeah. This is the given system of equations. Now, for this system of equations, we have to find the values of alpha and beta, for which the given system of equations have no solution, unique solution and many solutions. So, first write it in the form of Ax equal to B. Yeah. Now we have written it in the form of Ax equal to B. Now write the augmented matrix. Augmented matrix is the matrix A along with the matrix B. Yeah. After writing this in this form, now convert this given matrix, that is, convert the augmented matrix into echelon form. So, R2 implies R2 minus 2R1 and R3 implies R3 minus 3R1. So, upon applying these operations, yeah, this is the matrix which we get upon applying this with elementary row operations, these two operations. Now let us divide R2 with 1 by 2 and then make this 1 by 2 as 1. 0, yeah, with minus 1 by 2. So 0, 1, 0. Then this will become 3 by 2. Yeah, 0 to alpha minus 3, beta minus 24. Now let us make these two as zeros. So R3 implies R3 minus 2 R2. So it will become 0, 0, alpha minus 3. Then it will become beta minus 24 minus 3. Yeah. Beta minus 24, it will become beta minus 27. Beta minus 27. So these are the values which we are getting. Now this matrix is in echelon form. So once this matrix is in echelon form, now let us see the conditions for the values of alpha and beta. Now, what is the first condition? The system is inconsistent or it is having no solution when rank of A is not equal to rank of AB. That means if alpha equal to 3 and beta is not equal to 27, the system has no solution. The system has no solution because rank, in this case, what will happen, rank of A will not be equal to rank of AB and the system will not have any solution. Then coming to the second one, that is when alpha not equal to 3 and beta has any value. When alpha not equal to 3 and beta has any value, then the system has unique solution. The system has unique solution because in this case what will happen, the rank of A will be 3, rank of AB also will be 3 and it will be equal to the number of unknowns, that is also equal to 3. So in this case the system will have unique solution. Then when alpha equal to 3 and beta equal to 21, this, sorry, 27, the system has many solutions. The system has many solutions because in this case when alpha equal to 3 and beta equal to 27, rank of A is equal to rank of AB but it is less than number of unknowns, so the system has many solutions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.